Hello, here we are discussing forecasting. What is forecasting? We are trying to predict the future based on some data available from the past. That is it. Are we done here? No. So, there are different forecasting methods. We are going to deal with three. One is a simple moving average. So, in the simple moving average, we are trying to find the average for a fixed number of past periods. So, it's a moving average is a technique to get an overall idea of the trends in a data set, or it's just an average of any set of numbers. In this case, a t minus 1, that is actual occurrence of the past period. A t minus 2 is the actual occurrence of 2 periods ago, and so on up to a t minus n, which is the n periods ago, and take all those values and divide by n. That's it. Just average of a fixed number of past periods. It's extremely useful for forecasting long-term trends and can be used to calculate for any period of time. And it's useful when demand is not growing or declining rapidly and no seasonality is present. It is very important. Seasonality requires some more calculations. What is seasonality then? For example, in a post office, during the Christmas period, there will be higher requirement of workers or higher workload and than from a normal period. So we have to give some consideration to that seasonality, Christmas time, when we are trying to forecast the workload of a post office or postal service. Then that is where seasonality. In this case, we are not looking at seasonality, we are just looking at the average of the numbers. It removes some of the random fluctuations from the data, and longer periods provide more smoothing, and shorter periods react to trends more quickly. In simple words, you take the average. But remember that we need to have a certain specific number of periods to really make simple moving average happen. Now the next one is weighted moving average. I just talked about seasonality. What are we going to do for the seasonality? We have to give additional importance or weight to that period, right? So what I'm trying to say in this sentence is very important. In practice, the weighted moving average is usually employed when there is a need to place more importance on some periods over others. I repeat that sentence. This sentence exactly says why we should use weighted moving average. In practice, the weighted moving average is usually employed when there is a need to place more importance on some periods over others. So, for example, in the case of post office, we have to give higher weight during the period of Christmas time or something like that. The simple moving average formula implies all periods are equally important, right? The weighted moving average allows unequal weighting of prior time periods. The sum of the weights must be equal to 1. For example, if you are taking 0.4 for weight for one period, 0.3 for the other period, so it's already 0.7 is being used. You cannot give more than 0.3 to other periods. So make the sum of the weights must be equal to 1. Often more recent periods are given higher weights than period farther in the past. And experience and trial and error methods are used for choosing the weights. The recent past, of course, is given much higher weights than the distant ones. If the data is seasonal or data are seasonal, the weight should reflect this appropriately. Now the next is exponential smoothing. The simplest of the exponential smoothing method is called simple exponential smoothing, or SES, or sometimes called single exponential smoothing. This method is suitable for forecasting data with no trend or seasonal pattern. More recent results are weighted more heavily. Most used of all forecasting settings, because it's very simple. The user can understand how the model works. Little computation is required for this model. Computer storage requirements are small for this model. Now I repeat, a simple exponential smoothing model is used for forecasting data with no trend or seasonal patterns. Now somebody may ask, what happens if there is a seasonal trend, or what will happen? If there is a seasonal trend with no seasonality, we are going to use another technique which is called Holt's exponential smoothing. And if there is trend and seasonality involved, it is Winter's exponential smoothing, which is beyond your at this point of curriculum, it's beyond your textbook matter. If anybody is interested in knowing more about those, feel free to contact me. So basically we are trying to find a simple exponential smoothing, and in simple exponential smoothing, what you should remember is we are using an exponential smoothing constant called alpha. Okay, so this ft is the forecast value for the time period t. Ft minus 1 is the forecast for the previous time period, and at minus 1 is the actual time period. Let us look at the example. Here the forecasting f2 is f1 plus alpha into a1 minus f1. F1 is the 820 plus 0.2 into 820 minus 820. So it is how you got 820. In this case, F4 785 is F3 plus F3 is 811 plus 0.2 is the alpha smoothing coefficient and in smoothing constant into 680 minus 811, and similarly we found the other things. If you want to include trend, we have to include smoothing constant called delta, trend smoothing constant called delta, and that can take care of the trends. In the homework, we are going to deal with simple moving average, weighted moving average, and exponential smoothing. Hope it helps. Thank you.